Hi there, and welcome to another Papetti Math YouTube video tutorial where I'm going to be teaching you, yes, you, Algebra 1. And in this video, we're going to be looking at 6 different formulas that are used in all sorts of math and science, and we're going to be solving for a given variable. We're going to be rearranging that formula in a way that it asks us to. So it says that these are actual formulas used in math, chemistry, physics, and/or biology. And we're going to solve for the specified value. So it says solve d equals m over v for m. Now, if we have the formula d is equal to m divided by v, and this is our density formula that you may have seen already so far in your study of science or math, it wants us to solve for m. So we look at how m is not by itself because it's being divided by v. So the inverse of dividing by v is going to be multiplying by v. So I'm going to cancel out the v's over here because the inverse of dividing is multiplying. Those would cancel out, and I'd be left with m is equal to, I like alphabetical order, so m is equal to dv. And just like that, I solved the formula for m. M is now isolated. I'm done with that one. I'm ready for part B, which says solve K is equal to C plus 273 for C. So just rewriting it here, I'm going to look at this formula and look at how I need to get the C by itself. And again, you may have seen this one from science already. This is our formula to convert degrees Celsius to degrees Kelvin. And the way I'm going to isolate the C here is going to be to subtract 273, just one short step. And I'll be left with K minus 273 is equal to C. So just as I have a formula to convert from Celsius to Kelvin, now I have a formula to convert from Kelvin to Celsius. C is isolated, done with part B. In part C, I have solve v sub f equals v sub I plus at for a. So now I have a couple more steps. And this v sub f and v sub I are two different variables. You can't combine a v sub f with a v sub I. You can only combine the same variables with the same subscripts. And since these two variables have different subscripts, they're two different variables. And actually, this formula is used in physics and other areas of science and math. This is our final velocity with our initial velocity with acceleration in time. So this is a formula to find our final velocity, given a few other known pieces of information. But we're not concerned about that. All we're concerned about is isolating for a. So we're going to rewrite this formula. V sub f is equal to v sub I plus at. And since I'm solving for a, first thing I want to do is look for our addition or subtraction. I see that we're adding on the v sub I, so I'm going to start by subtracting v sub I from both sides. Now remember, they're not like terms, so I'm going to keep them apart. V sub f minus v sub I will remain v sub f minus v sub I, and I'll be left with a times t. And to get a by itself, I just said this was a times t, multiplication. So I'm going to undo that by dividing by t. And my answer is going to be a is equal to v sub f minus v sub I divided by t. This whole big mess over here is actually our final answer. Now we could solve for the acceleration given the final initial velocities and time. Now, in part D, we have d is equal to v sub I, there's that v sub I there again, times t plus 1/2 at squared. And this is a formula in physics, again, used for finding our total distance covered, given other variables. But again, we're not worried about that. We're just worried about getting v sub I by itself. So again, let me start off by rewriting my equation. And now I'm going to isolate by using inverse operations. I'm trying to get this by itself. So the first thing I'm going to do is I'm going to undo the addition here by subtracting 1 half at squared. Yes, just subtract that entire blob of constants and variables all at the same time. Nothing is a like term, so I'm going to keep it separate as d minus 1 half at squared is equal to v sub I times t. And I'm getting v sub I by itself, it says. So this is being multiplied by t, so I'm going to divide both sides by t. And that's going to give me a final answer of v sub I is equal to d minus 1 half at squared divided by t. Now there is actually one more step that you could do with this one. This would be a totally acceptable answer in Algebra 1, but if you saw that you could maybe simplify this a little bit further, since we have a t squared on the top and a t squared on the bottom, you'd want to divide both of these terms by t. So you're going to divide d by t, and you're going to get d over t minus, then you're going to do 1 half at squared divided by t, and you're going to get 1 half at is going to be equal to v sub I. Again, if you did not see that you could do this, don't worry about it. Don't do it. But if you did, you're in good shape. For this one, this is a perfectly acceptable answer as well. So either of these answers, whether you got this one or that one, perfectly okay. Don't worry about it if you didn't get this part over here. Okay? Moving on to part E is a formula that now might look familiar to you as the area formula for a trapezoid, and we want to solve for base 1. So we're going to get b sub 1 by itself by using inverse operations. I'm going to start off by rewriting my formula. And in this case, I could divide by 1 half h, but I don't want to, because then I'm going to be dividing by a fraction. So in this case, when I'm dividing by a fraction, I want to move the fraction by itself first. And remember, dividing by a fraction is the same thing as multiplying by its reciprocal. So I'm going to multiply both sides by 2 over 1, or just 2. So 2 times a is going to give me 2a is equal to, well, those will cancel out, and I'll be left with h times b sub 1 plus b sub 2. Now it's going to look a lot nicer when I divide by h to get inside to those parentheses, and I'll have 2a over h, because again, no like terms here, can't do anything further, is equal to b sub 1 plus b sub 2. Now what am I solving for? Well, b sub 1. So the way I get b sub 1 by itself is get rid of that b sub 2 by subtracting it to the other side. And my final solution will be 2a divided by h minus b sub 2 is equal to b sub 1. Right here, you could find your area of a trapezoid using this formula up top. Or if you were given the area, the height, and one of the bases, you could find the missing base using this formula down here, which might be helpful in your study of geometry. And finally, we have volume is equal to 1/3 pi r squared h, and we're solving for r here. So let's start off by rewriting that formula. Volume equals 1/3 pi r squared h. And just as I did over here, I want to move that fraction first. And when I divide by 1/3, it's really the same thing as multiplying by its reciprocal. So I'm going to multiply by 3 on both sides. And on the right side, I'll be left with just the pi r squared h is equal to 3 times v. I'm trying to get r by itself. So I look at the pi and the h are both connected to the r squared by multiplication. So I want to undo that by dividing both sides by pi and h, because they're all connected by multiplication. So multiplication is commutative. I could put that pi and h together. So now I have 3v divided by pi times h is equal to r squared. But again, I want to get r by itself, not r squared. So I need to know how to undo a square. And my inverse operation of squaring a number is taking the square root of the number. So that will give me r is equal to, because the square root will undo the squared, and I'll have r is equal to that whole big thing, the square root of 3v divided by pi times h. And this right here would be our formula with R isolated. So again, we did a lot in this video. We isolated variables in 6 different formulas that you'll see in your quest along studying mathematics, biology, physics, and chemistry. So now that you've seen from a simple one-step formula to a more complex 3 or 4-step formula, think to yourself, are you ready to move on? If you're not, I suggest you go back, watch this video again, take it through each step slowly, and see if you get it a second time. After that, if this video was helpful, make sure you give it a thumbs up below to let me know that this video helped you in rearranging formulas. And now you're ready for lesson number 4, and you can access that lesson by clicking on the link in this video provided. Thanks for watching.